thought that that word right there was arithmetic. I actually don't think you're crazy because it's actually spelled the same as the word arithmetic. And so, so yeah, that's kind of where that comes from. But I think when it's a noun, you use it. You say arithmetic. But in this case, we're using it as an adjective. It describes sequences and series. And so when it's used as an adjective, for some reason they pronounce it arithmetic. Okay, look at Mr. Barry with his parts of speech knowledge there, nouns, adjectives, all that good stuff. Okay. Um, so our essential questions here: how can you tell if a sequence is arithmetic, and then what kinds of functions or equations, or what kind is related to arithmetic sequences? So I think we'll be able to answer both of those today. Okay, an arithmetic sequence is a sequence in which the difference between consecutive terms is constant. So this is going to be a big idea here, the difference. And you can see our next vocab term here is the common difference. The common difference is the constant difference between terms of an arithmetic sequence. And we're going to be denoting that with a D, okay? Lowercase d. All right. Probably not on this video, or not right now, but on a part 2 video, we'll do an arithmetic series, which is again back to that sigma, the idea of sum, of adding everything up. Okay, so let's take a look here at our first example. And so we have a sequence here. Here it goes: -5, -3, -1, 1, 3. And we're going to determine whether or not it's arithmetic. So this is the official way to do this. Now, there is definitely a shortcut that I will show you guys right after we're done, but this is the official way, okay? So a sub 2 minus a sub 1. So if I'm following on this list, I'm going to subtract it, -3 minus -5, okay? So we are subtracting, but we're kind of subtracting backwards, right? A sub 2 minus a sub 1. Notice that, all right? So minus minus goes to plus plus there. I have this as a positive 2, okay? Now, the fact that that's positive 2 doesn't mean anything in and of itself. What we're looking for, if this is an arithmetic sequence, is that we want everyone after this to also be 2, okay? If they're all the same, then it is arithmetic. If even one is different, that kind of ruins it for everything, okay? So a sub 3 here. So a sub 3 is -1 minus a sub 2, and minus minus plus plus. Oh my goodness, that's also 2. Okay, we got a good streak here going. Remember, it has to continue. So let's see if it works again. So now we have a4 minus a3. So 1 minus -1. And it's also 2. Yes. Okay, we just have to get one more here. Let's see if it works. So 3 minus 1. Yes, it is 2. So since each difference is 2, the sequence is arithmetic. We can also say here, I would say that D equals 2. That's going to be a kind of key number for us on all of these is the common difference. So that was like the official way to do it. Now, do you guys want the shortcut? Okay, that's what I thought. So let's take a look back at the original sequence. And if you just do this, if you just track the pattern and you notice, oh, that's plus 2, that's plus 2, that's plus 2, that's plus 2. If it's consistent adding or subtracting of the same number, that is arithmetic. It's okay if it's subtracting the same number. That actually means that D is negative, and we'll see some examples of that. But consistent adding or subtracting of the same number, that's arithmetic. Consistent multiplying or dividing of the same number, not arithmetic, okay? That actually does have a name, and that's actually our next section is on what happens if it's consistent multiplying or dividing, but that's not arithmetic. It's got to be adding or subtracting, okay? Okay, let's go ahead and write the recursive formula for this. So the recursive formula, we know we always start off with a sub n equals a sub n minus 1. And then we just describe the pattern, right? So we noticed back here when I was kind of tracking the numbers that the pattern is a consistent plus 2. So I think that that's nice and easy to put there. Just a sub n equals previous term plus 2. So the common difference will always be featured in this recursive formula. And if it's a positive common difference, which means that the sequence is increasing, it's just going to be plus that number. If it's a negative common difference, which is the sequence is decreasing, then that's just going to be minus that number, okay? And then remember, for recursive sequences, we also always need to state that a sub 1, whatever that is. So in this case, our a sub 1 is -5, correct? So there's our recursive formula, all right? Okay, so let's take a look at these ones. If you want to kind of think ahead here, I'll pause for 30 seconds. Okay, so let's go ahead and do number 1. So I see here it is -5, and then I have a -6. So already I can stop right there. I could keep going here. You'll notice that there's even different common differences as we keep going. But once you have two that are not the same, you can automatically just say, no, that is not arithmetic, okay? That difference is not constant. Number 2 is a little trickier because obviously we're throwing in some variables there, but let's just think about what's changing as I go from here to here. Well, did the m change? I'm going to say no. In the first term, there's m. In the second term, there's m, correct? The number changed. So what happened? Well, I would say that we added 3. And then from the second term to the third term, you can see that we added 3 again, right? Okay. Now, if we wanted to do this the official way, like we did to start, we could also do that. So if I did a sub 2 minus a sub 1, I could do that, but notice I have to use parentheses, especially around the a sub 1, the second one, because then I have to distribute that negative. And you'll notice the m's cancel out and we get 3, correct? And then if I did that same thing and distributed the negative, so negative m minus 1 and m plus 4, that would give me 3 again. So we do get that common difference of 3. And so we can say a sub n equals a sub n minus 1. And then once again here, what's actually happening in this sequence? All that's really happening is we're adding 3 at each point, right? So my recursive formula is just going to be a sub n minus 1 plus 3. So where does m come into play? Well, I state that on my first term, right? So my first term is m minus 2. And then from there, I just keep adding 3 and adding 3 and adding 3. All right, numbers 3 and 4, we start dealing with fractions here. Whenever it gets tricky, if you can't do these in your head, then I would always just recommend you show your work, okay? So then I'm going to do a sub 2 minus a sub 1. So just remember how we kind of first did this, right? Once again, on number 1, when we can do it in our head, or even number 2, when you can do it in your head, feel free. But when it starts getting more complicated, when you have fractions, I would always just recommend you show your work. So we do a sub 2 minus a sub 1 is negative 3 over 2. A sub 3 minus a sub 2 is also negative 3 over 2. The tricky one here is a sub 4 minus a sub 3. Well, we know we're going to need common denominator there. So I'm going to call this negative 6 over 2. I'm going to switch this to plus 3 over 2. Just go and minus minus to plus plus there. And what do you know? That does also give me negative 3 over 2, correct? So we know that it is arithmetic. Our common difference is negative 3 over 2. We could say a sub n equals a sub n minus 1 minus 3 over 2. You could say plus a negative 3 over 2, but we know minus 3 over 2 means the same as plus a negative 3 over 2, right? Okay. And then a sub 1 equals what? Positive 3 over 2. How did I know that? It's just the first term in the sequence, right? Okay. All right, one more. Yeah, 1 over, I'm gonna show my work again on this one. So we'll do a2 minus a1. I'll go ahead and change that to 4 over 4 for my common denominator here, so I get negative 3 over 4. All right, once again, that doesn't really mean anything in and of itself. So I need to try now a3 minus a2 and see if that comes out to the same thing. I'll do both of these with a denominator of 36. So it's going to give me 4 over 36 minus 9 over 36, which is negative 5 over 36, which does not reduce, which means it is definitely not the same as negative 3 over 4. So that's going to be a no. Okay, so we did a lot of the explicit rule, or sorry, the recursive rule there, but now we're gonna switch over to the to the explicit rule. I think you might have, AKA, this is also known as the nth term. So if it's asking you for the nth term, it's asking you for the explicit rule. Honestly, I would always default to the explicit rule. All right, unless they really say recursive, I would use the explicit. Okay. All right. So here's our formula: d parentheses n minus 1 close parentheses plus a sub 1. Okay, but there's a lot easier one here for you to remember. So I'm going to write that one as well. They both work, but I actually prefer this one over here, dn plus a sub 0. Because I actually think this is the same as an equation that you guys already know. Let me show you the equation that you guys already know that's the same as this. Y equals mx plus b. It actually means the exact same thing, okay? D is the common difference that tells you how the sequence is changing, right? Isn't that the same idea as the slope? Like that's the slope. It's like this, it's up by 5, up by 5, up by 5. X and n are like the input variables, right? And then a sub 0 and b, that's like your starting point. Like where are you beginning, okay? So I'm going to be using mostly this formula. This formula always does work, okay? So let's take a look here at this next example. So what do we see here? Well, I noticed that the consistent pattern is minus 12, right? So that tells me that d equals negative 12. It's decreasing, so that's going to be a negative. Now, if I'm going to use my dn plus a sub 0 formula, what is a sub 0? There is, we know the first term, 57, is a sub 1, correct? So how do we find out a sub 0? Well, what I would say is, what if we did this pattern backwards? What if there was another number in front of this? Hypothetically, how would we figure out that number? Well, if we're subtracting 12 as we go right, it makes sense to me that we're adding 12 as we go left. So I would say that if there was another number in front of here, it would be 69. So now I can just use my formula here and say a sub n equals negative 12n plus 69. Now, what if I did this the other way? I can actually do that super quick. So what if I use the other formula, right? Would it still work? Well, I would say a sub n equals, d is still negative 12, and a sub 1 is 57, right? Well, what if I distributed that in there? Negative 12n plus 12 plus 57. What would that end up with? Negative 12n plus 69. Should you do that both ways? No. Whichever way you thought was easier out of those two, I would recommend. I always like using the dn plus a sub 0. I think it's a little bit easier personally, but a lot of people actually like the a1 version. One more question here, or the last part of this question is right here, where it says, what is a sub 19? So that's why writing an explicit formula is so nice, because now if we want a sub 19, we can just plug in a 19 in for n. I'm just going to use a calculator for this. So we get negative 12 times 19 plus 69. That gives us negative 159, okay? Awesome. Okay, so we'll wrap it up there. Let me stop recording.